Okay, welcome to 3.3, derivatives affecting the shape of the graph. We're going to learn about the first and second derivative test. First derivative test, we already know it. We already did it in the previous sections. All right, you're going to take the derivative, set it equal to 0. You're going to take those values, do a sign analysis chart, and we're going to determine if f prime changes from positive to negative. It has a local max, local min if f prime changes from negative to positive. We already talked about that. See these shapes? Now, these notes have you do a interval chart. I don't typically do that. It's just too much work. What I like to do is do a sign analysis chart. So what I'm going to do is take the derivative to find the local min and max. So you're going to take f prime. You're going to get 6x squared minus 18x plus 12. Okay, we're going to factor that. Go ahead and factor it. Set it equal to 0 and see what you get. Okay, so here's what we got. Factor out of 6. You're going to get x squared minus 3x plus 6. Set it equal to 0. You're going to get 6, and you're going to get x minus 1. Sorry, that's a 2, not a 6. Don't know how to divide. All right, minus 2 equals 0. So you get x is 1, x is 2. These values are called critical points. Keep that in mind because on the final they may ask you for critical points. All that is, take derivatives, set it equal to 0. Those are your critical points, 1 and 2. So make sure you know that because we're going to also add inflection points coming up in the next couple slides. All right, so here's how you do that. You make a sign analysis chart with those values. And again, we want to look at the slopes. So we're looking at the slopes. What is slope? Derivative. Remember I told you to remember that. So we're going to plug into f prime. So go ahead and plug into f prime, see what you get. Here's f prime, see what sign analysis you get. All right, you should get positive, negative, positive. Now this next part, I love to do this part. You don't have to, but I like to do it. If it's positive, I draw a slant like that. If it's negative, I draw it like that. And if it's positive, I draw it like that. So now you can kind of see, you got a peak there, you got a valley here. We worked on that with the dotted pink line in the two lessons ago. So here, this creates a local max at 1, okay? And here we have a local min at 2. But we want to find those values. Again, we want to find those local mins and maxes. So how am I going to find it? Think about it. These points are our critical points. You take those values, plug them back into the original function, and that'll tell you the y coordinate. These are our x coordinates. So we're going to find our y coordinate that corresponds. So we're going to go ahead and find our max. Okay? So we're going to take f of 1. And again, notice it does not say f prime, it's f of 1. If you plug it in, f of 1, plug in 1 here, you're going to get 10. Okay? So we got a max, f of 1 equals 10. Okay? And then, plug in 2, you're going to get the min. Plug it in the original, and you're going to get 9. All right, so there's our max, there's our min. And that's how the first derivative test works. When in doubt, take the derivative, set equal to 0, and all instances just about except for the mean value theorem. There you're going to set it equal to the slope that you find using the mean value theorem. Okay, so everybody good there? All right. So now we're going to talk about concave up, concave down, concave up, okay? Concave up if f prime is increasing, so it's negative 2 is the slope, then to negative 1, then to 1, and so forth. All right, then it's decreasing 1 to negative 1 to negative 2, and then back up. Now, these points where it changes from opening up to opening down to opening up, those are called inflection points, okay? Point of inflection is where the concavity, how it's concave, changes. Notice, f double prime equal to 0. So again, this time we're going to take the derivative, and then we're going to take the second derivative and set it equal to 0, okay? So, notice, those are the inflection points. Notice they don't occur here. They occur there. Those are only when the second derivative is equal to 0. All right? So again, concave up if the second derivative is greater than 0, concave down if the second derivative is less than 0. Tangent lines lie below functions which are concave up and above functions that are concave down. All right, so that is that rule. All right, so the second derivative test is, suppose f is continuous and f prime c and f prime of f double prime of c is greater than 0, then f has a local min at c. F prime of c equals 0, f double prime is less than 0, then f has a local max. Find the critical points and evaluate f double prime at these values. Second derivative test is inconclusive if f double prime is 0 or f double prime doesn't exist. That does happen from time to time. Alrighty, so we're going to go ahead and find our local extreme, our inflection points, and our intervals of concavity, okay? So, local extreme, again, those are local min and max. Set the derivative equal to 0. So we're going to go ahead and find f prime of x. So f prime of x is going to be 4x minus 4x cubed, okay? 4x minus 4x cubed. We're going to go ahead and set that equal to 0. So we're going to get 4x minus 4x cubed equal to 0. So you're going to get factor out of 4x. Negative, let's do negative, probably be easier that way. If you factor out a negative 4, you're going to get, this will become positive x squared minus 1. So that's going to give you negative 4x. You're going to get x plus 1, x minus 1, and then you're going to get x equals 0, x equals negative 1, and x equals 1. So we get x is 0, x is 1, x is negative 1. Okay. So there's our values. Do a sign analysis chart, putting negative 1, 0, and 1. And again, ask yourself, we're trying to figure out the slope, because we want to know, is it coming to a peak or a valley? So what we want to do is use the first derivatives. So go ahead and use the first derivative and fill out that sign analysis chart. Okay, welcome back. So when we do that, all right, plugging in our values, you're going to have sign analysis. If you plug in negative 2, okay, negative 2, you're going to get a positive, a negative, and a negative, so that's going to be positive, okay? From negative 1 to 0, you're going to get a negative, and positive, negative. So, when doing this, you're going to get a positive slope, negative slope, positive slope, and a negative slope. Okay, so negative 1, local max, 0, local min, 1, local max. Okay, so that's going to tell us what we got there. Okay, those are our local extrema. Okay, everybody got that. So then we're going to find our inflection points. So to find our inflection points are second derivative set it equal to 0. So I'm going to take the derivative of that, so you're going to get 4 minus 12x squared, set it equal to 0. All right, you're going to solve that. Okay, now these kind of get ugly, because once you start doing the second derivative, you get these ugly functions. Hopefully, on the final, they wouldn't give you a very difficult one, but you're going to get 12x squared equals 4. So x squared equals 1 over 3. So x equals plus or minus square root of 1/3. Okay, 1/3. Okay? So that's going to be 1 over square root of 3. Don't worry about rationalizing it, doesn't matter. Okay? So we want to find the inflection points. Points have an x and a y value. Here, oh, it's plus or minus. Here are our x values. How do you find your y values? And again, we got to think. Going back to our picture, okay? Our inflection points are on the original graph. So if we want to find them, we found our x values. Now, how do we find those points? Plug them into the original. So what we're going to do is take this function, plug it into the original function here. Go ahead and do that, see what you get. All right, so you get f of positive 1 over square root of 3. And again, these do get ugly. You might need a calculator for that. So you're going to get 113 over 9 And again, you're going to plug in f of negative 1 over square root of 3, and you're going to get 113 over 9. So, your inflection points are 1 over square root of 3, 113 over 9, 1 over square root of 3, 113 over 9. Those are your inflection points, x and a y coordinate. Now for intervals of concavity, Now again, all right, this is very similar, but think of concavity has to do with your inflection points, not critical points. So when we do this, we want to do sign analysis on our inflection point. So, oh, sorry, this was supposed to be negative, sorry. And then positive, all right? So we want to do sign analysis on this. Okay, sign analysis, all right? Okay, so we're going to plug that into the original. This is going into the original. Go ahead and see what you got. Okay. All right, again, going back here, it's concave up if the double prime is greater than 0, concave down if it's less than 0. So, going back to our sign analysis here, you should have got negative, positive, negative. Okay, so that's going to tell me concave down in this interval, concave up in this interval, concave down in that interval. Okay, so that's what it's going to tell me. All right, so we have concave down, okay, and that's going to be from negative infinity to negative 1 over square root of 3, union 1 over square root of 3 to infinity. It's concave up, all right, and that's going to be between negative 1 over square root of 3 to 1 over square root of 3. Again, second derivative does get a little funky. You got to watch yourself on that. The numbers will get kind of weird. Okay, some kind of weird. All right. All right. That's it. Oh, we have one more slide. Sorry. Okay, so at which of the 5 points on the graph are the derivative and the second derivative both positive? So where is that at? Okay, so we're looking for slope being positive and it being concave up. Well, here is a positive slope, but it's concave down until about right there at that inflection point. So not that. This is clearly not it. B slope is negative, so again, not that. Here, that slope's negative, so it can't be there. Here, the slope is 0, not positive, so that leaves us with one last. Let's take a look. The tangent line is positive, so that's the first derivative. Second derivative is positive. Why? Because this function is concave up there and concave down there. So if it's concave up, we know the second derivative is positive, and here, so the answer is E. Okay, E. All right.